Welcome back, everyone, to AI Talks with Chris and Nita, episode 30. Can you believe it? And today we're diving into something pretty cool. I think, I think it's cool anyway. We're looking at Iterative Deepening A, or IDA.
Yeah, this one's a classic.
It really is. I mean, who doesn't love a good search algorithm?
Especially one that's as clever as IDA.
Exactly. So for our listeners who maybe aren't as familiar, can you give us a quick rundown of what IDA is all about?
Sure. So at its core, IDA is all about finding the shortest path between 2 points. You know, like how do you get from point A to point B in the most efficient way possible?
Right, like when your GPS is trying to figure out the fastest route.
Exactly. But it goes way beyond just GPS. I mean, we're talking applications in robotics, game AI, you name it. Anywhere you need to find the optimal path, IDA can be a real game changer.
Okay, so it's a path-finding algorithm. But what makes it so special? There are tons of path-finding algorithms out there, right?
Right. But IDEA has a few tricks up its sleeve that make it really stand out. One of the key things is that it's incredibly memory efficient. Unlike some other algorithms that might try to explore every single possible path at once, which can be a real memory hog, IDEA uses this clever technique called iterative deepening.
Iterative deepening, huh? That
Yeah.
sounds kind of complicated.
It's actually pretty intuitive when you break it down. Basically, IDEA starts by exploring paths up to a certain depth. If it doesn't find the goal within that depth, it increases the depth limit and tries again. And it keeps doing this, iteratively deepening its search until it finds the shortest path.
So it's like it's gradually expanding its search horizon until it hits the target. That's pretty smart.
It is, and this iterative approach is what allows it to be so memory efficient. It only needs to keep track of the paths it's currently exploring, not the entire search tree.
So it's finding the best path without overwhelming your computer's memory. That's pretty important, especially if you're working with limited resources.
Absolutely. And this makes IDA really well suited for applications like robotics, where you might have a robot with limited onboard computing power.
Okay, so we've got the iterative deepening part. But how does IDA actually decide which paths to explore in the first place?
That's where the A part comes in. IDA uses what's called a heuristic function to guide its search.
A heuristic. Okay, now you're just using fancy words to confuse me.
No, it's not that complicated. Think of a heuristic as kind of like a rule of thumb. It's an educated guess that helps the algorithm estimate the cost of reaching the goal from a particular point.
So it's like a shortcut for making decisions about which paths are more promising.
Precisely. And in the case of IDA, the heuristic function is designed to never overestimate the actual cost. This is super important because it guarantees that when ID finds a solution, it's truly the shortest path, not just some close approximation.
So it's like having a GPS that you know will always give you the absolute fastest route no matter what.
Exactly. And this property of never overestimating the cost is what makes the heuristic admissible.
Admissible.
Got it. So we've got iterative deepening for memory efficiency and an admissible heuristic for making smart decisions about which paths to explore. That's a pretty powerful combination.
It really is. And it's why IDA is such a popular choice for all sorts of pathfinding problems. I mean, think about it. You could use IDA to plan a robot's movements through a factory floor or figure out the best sequence of moves to win a game of chess. The possibilities are endless.
It's amazing how such a seemingly simple concept, finding the shortest path, can have such a wide range of applications.
It is, isn't it? And, you know, what I find particularly fascinating is how IDA kind of mimics the way humans solve problems. We often use heuristics and a kind of iterative approach when we're trying to figure things out.
That's true. I mean, if I'm trying to find my way through a new city, I don't usually plan out every single possible route beforehand. I kind of start walking in a general direction and adjust my path as I go, based on what I see and what seems like the best way forward. Exactly. And in a way, that's what IDEA is doing as well. It's using its heuristic to guide its search, but it's also constantly reevaluating its options and adjusting its course as needed.
So it's like a dynamic problem-solving process, always adapting to new information. That's pretty cool. And I think it speaks to the power of algorithms like IDEA. They can not only solve problems efficiently, but also do so in a way that's surprisingly human-like.
I completely agree. And it makes you wonder, what other problems could we solve using this kind of approach? What other areas of our lives could benefit from algorithms that are as clever and adaptable as IDEA?
That's a great question to leave our listeners with. As you go about your day, think about the paths you take, the decisions you make. Are there places where you could apply a little bit of IDEA thinking? Could you use a heuristic to guide your choices or an iterative approach to break down a complex problem into smaller, more manageable steps?
Food for thought.
Definitely. And with that, we'll wrap up this deep dive into the world of IDEA. Until next time.
See you then.
Bye, everyone.